One of the biggest challenges to using the cloud is getting your software onto your cloud machines. This is especially challenging among Python developers because their software changes on an hour-by-hour basis. The de facto standard here is to use Docker images, but a lot of the people that we've seen trying to do data work on the cloud are not very familiar with Docker. It's not a common tool for them. In Coiled, the standard answer for this is we've got automatic package synchronization. So I'm going to create a cluster, and what the cluster does is it inspects my local environment wherever I'm calling from, in this case, my MacBook Pro, and it is looking at all the Conda packages I have installed, all of the pip packages I have installed. It actually notices I've got a development version of a package here, DAS expressions, and it's making a wheel for me automatically, and it is shipping up that specification to the cloud. And once my workers have arrived, it will download all of those packages to each of those workers. This is one of Coiled's most beloved features. People don't have to make Docker images. The stuff on their machine just kind of magically appears on their cloud machines. And it's really, really nice. People love it. Sometimes it doesn't work. And that's because this usually happens early on in someone's using Coiled. They install it for the first time. They're really excited. They create a cluster, and they're running from some Python environment that they've had for years. And it has, for years, accumulated lots of interesting development packages into it. And some of those packages just break the magic of this system. The system is not infallible. In those cases, honestly, what usually happens is they just make a new fresh software environment with Conda, with Mamba, with virtualenv, with pipenv, with poetry. Any package manager is fine. But they make a new virtual environment and they start from there. And then things are fine. So that's usually the solution that people go to. But there's a couple of other approaches that I want to mention here for completeness' sake. One is you can always specify a Docker container. So there's, for example, I can specify the dask dev, dask Docker container, works just fine. Your Docker image must have dask installed, and particularly you must be able to run the dask spec CLI command. That's one option. This is especially useful with groups that are already really Docker-centric, or groups that have software that is never going to be installable through Python means. Another approach, which is common for folks who really want to lock down their environments and not have this kind of automatic synchronization, is manual software environments. So Coiled has a create software environment function where you can specify Conda packages, pip packages, etc. Let's go and do that ourselves. So let's specify a software environment. We will call it dev, as opposed to maybe prod, for example. And we can specify a Conda, packages, maybe dask and pandas, or we can get even more specific and specify, channels. Let's add, the Conda Forge channel, and we'll do dependencies. We'll add, dask and pandas, and we might, get even more special. We might look at, basing that, also adding on top of that some pip packages, maybe from some, GitHub, address, for example. We might also base all of that on a container, right? Maybe we have sort of a base container. We layer on Conda packages. We layer on pip packages. We can specify lots of things if we want to. Then when we go to create our clusters, we're going to use this name, right? So up here, we're going to say software equals dev. This is a way to be very specific and very particular with your packages, but you do have to make sure that your local environment is going to match those same versions, and that can be frustrating. So again, lots of different ways of specifying containers or software packages with Coiled. By default, we recommend just doing nothing. And for most users, the automatic synchronization feature handles everything. If it doesn't, either use one of the 2 escape hatches I just mentioned, or just make a fresh Python environment. That's it. Hopefully that helps. Cheers.